Figure 6E12 shows a small block of mass small m kept at the left end of a larger block of mass capital M and length L. The system can slide on a horizontal road. The system is started towards right with an initial velocity v. The friction coefficient between the road and the bigger block is mu, and that between the blocks is mu by 2. Find the time elapsed before the smaller block separates from the bigger block. So here this is smaller block whose mass is small m, and this is bigger block whose mass is capital M, its length is L. Now, in order to the mass small m gets separated from bigger mass, it has to cover extra length small l. So now let's consider the various forces. So here friction between the two surfaces is mu by 2. So we can say in this direction there is friction Fr1. Fr1 will be equal to mu times mg. So here mu is mu by 2 and mass of the block is small m into g. Now acceleration on this block can be found. So we can say due to this friction, this block is in motion. So ma1 equal to mu by 2 mg. So m will cancel out and we will get a1 equal to mu by 2 g. Now, if we consider the lower block, so here its normal reaction is suppose n and its weight is mg, and also due to this block, due to smaller block, there will be a reaction. So that is suppose R1. So value of R1 can be found by considering like this. Its weight is small mg. The reaction is R1. So this will be same, equal and opposite reaction. So we can say that N equal to mg plus R1 and R1 equal to small mg. So m plus small m into g. Now we can find Fr2, the friction between the ground and the bigger block. So Fr2 will be equal to mu times capital M plus small m into g. Now, since there is friction in this direction when the two blocks move, so as a reaction, there will also be the same friction in this direction when we consider the lower block. So we can say net force acting on the lower block will be equal to MA capital M times A. Let's acceleration of this bigger block is A2. So we can say MA2 equal to total force, that is Fr2 minus Fr1. Fr2 minus Fr1. So Fr2 will be mu times capital M plus small mg minus Fr1 we have found as mu by 2 small mg. Now we simplify it. So we can get the value of A2. This portion can be deleted. So from here, A2 will be equal to, here we can divide by m and we can take common this. So we write here 2m and then mu times capital M plus small mg minus mu. So there is mistake. Let's write it again. So we have this thing MA2 equal to mu times capital M plus small m times g minus mu by 2 small mg. We have to divide each term by capital M. So A2 will be equal to mu upon we can write mu times m plus m into g minus mu by 2 mg whole divided by m. So we can take LCM. This 2 will get multiplied to this term also. So 2 mu g times capital M plus small m minus mu mg divided by 2m. Now, this will become, if we simplify further, so if we open the bracket, or we can take out mu g from here. So 2 mu g outside, then what is left? So we will get from here, this will become, since 2 is not present here, so it is better to take just mu g common. So mu g common. So we have 2m plus a small 2m minus a small m whole divided by 2m. So it will be equal to A2 equal to mu g upon 2m. 1m will cancel out from here. So we will get 2m plus small m. So we have got the value of A2 also. Now, we have A1 equal to mu by 2g and A2 equal to this much. A2 equal to this. So now we can apply the equation of motion for the two blocks. So S1 is distance covered by first block equal to ut. Here u is vt plus half a1 t square, and S2 equal to vt plus half a2 t square. But first body has to cover L meter more to get detached from the bigger one. So for that, we can say S1 minus S2 must be equal to L. So if we subtract the two equations, so we will get L equal to 1 by 2 A1 minus A2 times T square. Here we have to take the absolute value of A1 minus A2 because this is square term. So we can say 12 upon modulus A1 minus A2 under root thereof will be equal to T. So let's find out what is A1 minus A2 and then its modulus. So A1 minus A2. A1 is this much mu g upon 2 minus A2 is this much mu g upon 2m times 2m plus m. Now, if we take LCM, it would be 2m, then m will get multiplied, capital M mu g minus, this is 2 capital M mu g minus mu small m g. Now further we simplify. From here we will get minus capital M mu g minus small m mu g divided by 2m. We must take its modulus because both terms are negative. So if we write the modulus value, so we will get modulus A1 minus A2. A1 minus A2, or we can also say this is a relative value, A relative. So that will be equal to mu g we can take common, then capital M plus small m divided by 2 capital M. So we have got this value and we can write here. So T will be equal to root of 2L divided by this value mu g times capital M plus small m, and this 2m will go in numerator. So this will become 2m. So we have got 4 capital M small l divided by mu g times capital M plus small m. And that is the time taken by small block to get separated from the bigger block. Thank you for watching.